You are watching a quiet revolution. These are Pakistani workmen, members of an age-old civilization, but citizens of a nation independent for just 2 decades. They are at work on a project which will restore the historic fort of Mangla, built 100 years ago on ruins dating back more than 5 centuries. The parched and arid land where the fort stands has been the pathway and battlefield for men and armies since the time of Alexander the Great. Today, the nation of Pakistan looks in 2 directions, to the heritage of the past and to the promise of the future. On the Jhelum River below the fort is another project, a new dam and powerhouse. Together, they will provide electricity to power a nation's expanding economy. And they will control and distribute the waters that for centuries have been both the scourge and the lifeblood of the Indus Basin. Like all people in all times, the people of Pakistan are dependent upon water. Civilizations have flourished and faded with the successes and failures of their water engineers. Without access to and some control over water, human life at its simplest and its most complex would be impossible. The record of man's response to that fact constitutes much of the history of civilization. For centuries, life in this land has been tied to the flood-washed Indus River Valley that stretches 1,000 miles southward from the Himalayas across broad, fertile plains to the Indian Ocean. For centuries, men have used irrigation systems that tap the streams and rivers, as well as underground water tables fed by the Indus and its tributaries. In the dry seasons, water was brought to the land by the plodding hoof in the dust, the turning bucket, the squeaking wheel. Thousands of wheels, thousands of men, thousands of wells. But the process of change occurs even here. In 1947, this ancient land became the new nation of Pakistan. And with the creation of national boundaries, this man's very existence was threatened. For now, the headwaters of the rivers and control of their flow lay across the border in India's Himalayan highlands. It meant Pakistan could be left without water. In 1948, the 2 nations entered into negotiations over the basic water rights to the 6 rivers in the Indus Basin. Years of high-level talks moved ahead slowly, far from the reality of the arid farmlands and their threatened wells. Unless a solution were found, the waters could be diverted upstream before reaching Pakistan. The rivers would run dry. The underground water would disappear. Pakistan could become a desert. Finally, in 1960, Pakistan and India signed the Indus Basin Water Treaty. India received rights to the waters of the 3 eastern rivers, the Sutlej, the Beas, and the Ravi. Pakistan was ceded rights to the 3 western rivers, the Chenab, the Jhelum, and the Indus. Even before the treaty was signed, the government of Pakistan was hard at work on a water development plan. 2 major dams, Tarbela on the Indus and Mangla on the Jhelum, would provide irrigation storage, flood control, and electrical power. A series of barrages and link canals would provide a system to replace the lost irrigation waters of the eastern rivers. The responsibility for managing this costly and complex undertaking was assigned to the West Pakistan Water and Power Development Authority, called WAPDA. Consulting engineers for the Indus Basin Plan were Harza Engineering Company International. To design and supervise construction of the Mangla project, WAPDA retained Binney and Partners of London. 2 years of work developed the specifications for the Mangla project. The reservoir would be contained by 2 dams, Mangla on the Jhelum and Jari 12 miles to the east. Along a low ridge between the 2 dams, the Sukian dike would be built in order that the lake could be raised to its designed height. The main dam alone would be 375 feet high and more than 2 miles long. The construction plan at Mangla called for the boring of 5 2,000-foot-long tunnels, each 36 feet in diameter. The powerhouse design by Priest, Cardew, and Ryder called for an ultimate potential of 1 million kilowatts. The Harza-designed main spillway would be almost half a mile long and have the capability of handling a maximum flow of 900,000 cubic feet per second. An emergency spillway could handle an additional 230,000 cubic feet per second. Because of the size and complexity of the job at Mangla, only 4 international groups pre-qualified and bid. Financed through the World Bank, the contract would be a fixed unit price award. On November 15, 1961, the bids were read publicly, and the award went to the low bidder, Mangla Dam Contractors, a group of 8 American firms led by the Guy F. Atkinson Company of South San Francisco. Atkinson, as managing partner, was joined in the venture by the Chicago Bridge and Iron Company, S.J. Groves & Sons Company, Charles L. Harney Incorporated, C.J. Langenfelder & Son Incorporated, Ostrander Construction Company, R.A. Trappier Incorporated, and the Walsh Construction Company. This was the group that received the world's largest peacetime competitive bid award, nearly $354 million. The contractor's work on Mangla Dam began at the Atkinson main office in South San Francisco. The first step was meetings, lots of them. Their purpose to implement the plans and procedures that would be used to build the dam. One of the early decisions, based on pre-bid studies, was to advance the completion date by a full year. But the potential danger of sudden catastrophic monsoon floods on the Jhelum River meant that closure and diversion of the river must be accomplished as early as possible in September, the end of the monsoon season. Diversion at this time would allow the maximum time to raise the closure dam high enough to withstand the next season's floods. If diversion couldn't be completed on schedule, it would have to be postponed a full year. This potential threat was the key to many other basic decisions that had to be made by the planning groups. Only the best and most modern earth-moving equipment could handle the job, and it would take the world's largest peacetime fleet to do it. $50 million worth had to be selected, ordered, and shipped at once. They would have to plan, too, for the maintenance shops, to supply warehouses, and the town to support the equipment, the men, and their families. Another assignment was to select the 500 experienced construction personnel who would supervise, train, and work with the thousands of Pakistanis who would make up the labor force. From the contractor's office in South San Francisco, from job offices in London and Karachi, and from key people around the world, things started moving toward Pakistan. In a place far from the technology and amenities of the modern world, a dam would be built. At Karachi, shiploads of equipment and supplies were now arriving. They would be transported the remaining 900 miles north to Mangla by rail. The logistics of just getting the job started were enormous. Items large and small, cheap and expensive, were on the way. Earth-moving equipment from California, diesel fuel from Asia, school books from New York, beef from Australia. And yet, within 2 months, things were underway at Mangla. The supervisory staff would be drawn from Atkinson's permanent organization. They would go to the job from many points: Los Angeles, San Francisco, Portland. There they would meet families from Liverpool, Manchester, and London, sent by the project's consulting engineer, Binney and Partners. With their counterparts in Wapta, these men would spend the next 5 years supervising the construction of Mangla Dam. This meant building the homes, the hospitals, the supermarkets, the schools, the labor camps, everything that would be needed. The first job, to organize the facilities needed to support the thousands of items and people that were pouring into the site. It meant getting the equipment and materials with which the dam would be built. And it meant building the shops needed to repair and maintain the heavy equipment. It meant building the facilities to store and repair, to service and maintain everything that was coming to Mangla. For the job of constructing an earth-filled dam isn't just piling up a lot of dirt and rock. The components of the dam would come from a variety of places, some of it rock blasted from a quarry in the nearby hills. core material would be from a site on the Jhelum Riverbed 3 miles below the dam. And there would be clay and sandstone from the surrounding hills. Over a third of the fill for the main dam would come first to the aggregate plant, where in an hour's time, 12 crushers, 26 screens, and 10 miles of conveyor belts would turn out over 3,000 tons of drain and filter rock, ranging in size from fine sand to cobbles. Yet the aggregate plant would be so highly automated that only 8 people would be required to keep the operation running at full speed. And it also meant hiring the workforce. Since the availability of trained personnel in Pakistan was not sufficient to meet the immediate demand, a local workforce must be hired and trained. Even basic skills with simple hand and power tools would have to be taught. Men who had never before seen a bulldozer or a scraper or a crane would have to become totally familiar with equipment worth thousands of dollars. The contractor used his own experienced operators to teach how to push a scraper with a cap, how to make a well, how to repair a diesel engine, how to pour concrete. Initial instruction was in English, which was then translated by a Pakistani foreman. The next step was to gain experience on the actual equipment. The instructors never worked their training units in an area where major operations were underway. Instead, they utilized future construction sites where even practice work contributed to the job to be done. More than 10,000 untrained but eager men learned the skills that were needed. Skills for the job at Mangla, and skills readily usable in the accelerating technology of the new Pakistan. The contractor's first year in Pakistan had been spent organizing facilities, equipment, and manpower. But even before the first year was out, construction was underway on the dam itself. The river had to be diverted at the end of the monsoon season to allow time to raise the dam high enough to withstand the annual spring floods. The schedule called for diversion by September 1965, a deadline now only 36 months away. In order to meet that deadline, a number of projects had to be well underway. At the diversion site, 8 million cubic yards of material was being torn away from the cliff face. Only a thin rib of rock and earth would be left as a cofferdam to hold the river out of the worksite at the mouth of the tunnels. At the downstream end of the tunnels, the powerhouse area was being excavated in preparation for the pouring of foundations. Below that, work on the tail race was getting underway. But diversion didn't depend just on this. The base of the main embankment had to be excavated to foundation, and the first clay laid in that would form the impervious core of the main dam. This clay for the core, although readily available, required special treatment. Because it was so heavily compacted, a great deal of time was required to break the clay down so that it could be laid for the core. Disking, watering, grading, and more disking went on until the clay was finally of proper consistency. 12 miles away, similar work was underway on the Jhelum Dam. Overshadowed by the larger Mangla Dam, Jhelum was still a project of considerable size, running over a mile in length and topping out at a height of 234 feet. Before long, the main embankment began to take shape. Plans called for it to be brought to a height of 223 feet, along 10,000 of its 11,000-foot length. A 1,000-foot gap would be left at one end below the old fort. The Jhelum River would continue to flow through here until diversion. The zones and layers of controlled materials for the main dam would consist of rolled sandstone and clay mixtures, rolled clay for the core, washed gravel, and riprap for the exterior surfaces. A series of drainage wells would be placed along the dam's entire length. At the tunnel intake site, excavation had laid the mountain bare, and the largest tunneling mole ever built began boring its way through the face of the exposed cliff. The mole was untried. No one was yet totally sure it would do the job. And at first, results were disappointing. Extreme stresses caused jamming. Cave-ins often meant more hours clearing and changing the cutters than were spent tunneling. If the problems couldn't be corrected, diversion date might have to be put off. And that would mean an extra year of construction, a 20% lengthening of job time, and millions more in costs. On-the-spot refinements and adaptations were made. The mold's cutting surfaces were improved, and the hydraulic pressure pushing the cutting head against the rock was increased. It had taken 90 days to bore the first tunnel. The second was cut through in half that time, sometimes making good as much as 105 feet a day. As the mold dug forward, crews followed behind, shoring up the ceiling to prevent cave-ins. After them came the concrete crews, lining the tunnels so they could withstand the erosion and pressure of the millions of gallons of water that would race through on its way around the construction site. Further strength was supplied by steel tunnel liners. 30 feet in diameter and 30 feet long, these huge segments were fabricated on the job, loaded on trucks and transported to the tunnel site, where they were set in the tunnels and welded in place. At the intake area, the tunnel portals were poured and the control gates were installed. When open, these gates would allow water to pass into the diversion tunnels. When closed, the impounded waters would form the lake. At the downstream end of the tunnels, other crews were hard at work laying the foundations for the powerhouse. Initially, 3 generators would be tied into the tunnels. Water stored behind the new dam would pass through the tunnels to spin the rotors that would create 300,000 kilowatts of electricity. Ultimately, Mangla would be able to generate a full 1,000,000 kilowatts of power from 10 generators. Of organization that preceded were paying off. On a job where literally thousands of things were happening at once, every situation was under direct control and observation. Availability of men and materials, cost control, equipment at the right place at the right time. Work was carefully watched and directed from every management level. The constant challenge at this stage was the approaching deadline of diversion date. Field men moved back and forth between their specific jobs on the site and the main office, checking and double-checking each of the details that was a part of the complex job. They pitched in whenever needed to lend an extra hand. It went like this until it was the fall of 1965. Then, less than a month before diversion with everything on schedule, Pakistan went to war. The battlefront less than 50 miles away. The workforce reduced by a third. Mangla Dam contractors waited for word from the government on whether or not to proceed with closure. In the meantime, all preliminary work continued as though closure would take place. The rid between the river and the tunnels was cleared. Diversion time was now. If not now, work would have to be delayed a full year. At last, the decision came. Diversion of the Jhelum at Mangla must proceed. Almost 5 years to the day from the signing of the Indus Water Treaty, the course of the Jhelum River was turned through the tunnels and the riverbed ran dry. Now work crews could move into the riverbed gap at the main dam site and begin to excavate to foundation. Diversion had been one of the key dates on the job. Everything to this point had focused on that one event. Now there was a shift of emphasis. The entire purpose of all work from now on was to get each part of the job finished as quickly as possible. Maximum efficiency was the keynote of the entire Mangla operation. And to keep things running at that rate meant thousands of spare parts carefully stored, their location and quantity filed and cross-indexed to assure ready availability. Because of the remoteness of the job, it was necessary to stockpile everything from carburetor jets to automatic transmissions to complete engines. 1,200 mechanics, most of them trained on the job, kept everything running. But you can only repair and replace for so long. Eventually, a complete overhaul is required. Crankshafts had to be reground. Diesel engines had to be stripped apart and reconditioned. The hard surface metal was replaced on tractor rollers. When you're 3 months away from your nearest source of supply, the simpler you can make life, the better. For all of this, the equipment and the people who could do the job were at Mangla. When you've got 13,000 workmen on a job, communications is a problem. When they speak different languages, it can be even more of a problem. As the job at Mangla became more complex, so did the lives of the people. Basic safety practices had been emphasized from the beginning. A fully equipped fire department was on duty continuously. It served both the job site and the community. Emergency ambulances were stationed at key points, ready to aid injured personnel or speed them to the hospital for medical attention. The modern 80-bed hospital was fully equipped and staffed. Here, all medical problems could be handled, from the routine matters of minor home and job accidents to major surgery. A hospital isn't the only place where proper diet is essential. Realizing this, the contractor established a 25-acre food farm. Poultry, eggs, fresh produce, from bananas to corn, to okra, to lettuce and melons. Practically everything was grown at the farm, which supplied fresh produce to the labor camps and to the Baral Colony supermarket. Sometimes you want more than groceries, and the supermarket was just part of the complete shopping facility at Mangla. The colony was by now a thriving town with 500 homes, and bachelor quarters for 110. The key personnel the contractor had brought here were a long way from the States. But in this case, they were about as close to home as they could be, and still be 9,000 miles away. Because of the duration of the project, families would spend at least 30 months at the job site. Some of them would remain throughout the entire job. The town resembled a modern American community, complete with all the activities of suburbia. It may seem an extravagance to create a small-town USA in the desert of Pakistan, but the colony proved to be a most economical expenditure. The International Elementary School was complete from playground to PTA.
These are all wooden structures. So we've got
Just because they were a long way from home didn't keep the kids from acting like they always do.
Now, the next very important thing that you've got to have done is what? Not the plumbing at all. Who's the one that's going to come along and do the plumbing?
Students in the high school had a full and complete curriculum. With a diploma from the high school, a graduating senior was prepared to qualify for admission to any American university or college. A special section of the school library served the community as well. But it wasn't all work. Recreation facilities were abundant, including 2 swimming pools, one of Olympic size. And there was recreation for the adults, too. Golf on the 9-hole course at the country club, complete with Club Pro and a rope tow for that long climb back to the clubhouse from the last green. In the evenings and on weekends, there was bowling on the 10 lanes at the Mangla alleys. There were some pretty fair averages, and a few who would just as soon forget about the whole thing. A fine restaurant with a menu of gourmet delights was a popular place to get together. About all Mangla lacked was a freeway traffic jam. By now, excavation was complete, and the concrete crews were at work covering the 55-acre area of the main spillway. Supports for the pre-stressed concrete spillway gate anchorages were being placed. The spillway design is a submerged intake type with 9 radial gates, each 36 feet wide and 40 feet high. The pressure was still on, and work went ahead at full speed. Sometimes other things went ahead at full speed, too. With a 2-day holiday coming, payday is important. Important, too, was the contribution of the Pakistani workmen and foremen. These are the men who had never seen a scraper, a cat, or a power shovel. Yet, these are the men who operated 1,000 pieces of specialized equipment, 2 shifts a day, 6 days a week. And these are the men who, in their best month, moved 4 million yards of earth fill. To meet the next important deadline, impounding of the river's waters behind the dam, work was going ahead at an equally rapid pace on both Jari Dam and the Sukian Dike. Here at Jari, the main embankment was already established to a level of nearly 200 feet. The irrigation intake tunnel was nearly completed, as was the outlet and the tail race. As soon as the levels of all embankments were of sufficient height, impounding could begin. The gates at the upstream end of the diversion tunnels were closed on February 21st, 1967, and the lake began to rise behind the dam. It took just 1 month for the lake level to reach the spillway elevation, and on March 21st, the first water passed over the giant structure. But the big job at Mangla was fill. All told, the contractor would eventually place 145 million cubic yards of fill on the 3 dams. 2 shifts were now utilizing a fleet of 75 wagons of 100-ton capacity and 80 scrapers, each with a capacity of 40 cubic yards. Ahead of the rising lake, riprap was placed on the upstream banks. Now the various aspects of the project were nearing completion, and as each was finished, it was turned over to the West Pakistan Water and Power Development Authority, who would now be responsible for its operation. Fill work on the main dam was completed in June 1967, almost 5 years after initial excavation had started some 375 feet below on the riverbed. A month later, Jhelum Dam received a certificate of completion. And at the same time, a special ceremony was held and the main spillway was placed under Waptish control. Now, work at the powerhouse became critical. Pakistan wanted electricity. The sooner the better. Engineering crews rushed to finish final tests on the generators. On July 3rd, 1967, number 1 received its okay, and power went on the line. But work at the powerhouse didn't let up. Much remained to be done. The first butterfly valves had been assembled in place near the turbines. Now that procedure was changed. The valves were pre-assembled, then moved on a skid to the powerhouse for installation, along with the other power-generating components. The project at Mangla was almost complete. At the eastern end, Jhelum Dam was releasing waters into the downstream irrigation system. The Sukian Dike now stretched along its complete 3.5-mile length, and the last riprap was being placed and combed. The emergency spillway was now complete. The main spillway with its 2 stilling basins is one of the largest ever built. 29 million cubic yards of earth were cleared away for it, and almost 1.25 million cubic yards of concrete were required to form the massive structure. If during flood time the lake level were to increase 26 feet above conservation level, the gates would pass a jet of water 18 feet deep, 444 feet wide at a speed of 90 miles per hour into the stilling basins. In its small way, the old Mangla headworks was able to divert some of the Jhelum's waters to better use. But now the Jhelum is harnessed. Now there is water to irrigate the land. Now there is electricity for industry. Now there is water to put back in the dry riverbeds. More than enough. The new Bong escape sends some of it down country through a series of canals, returning the excess to the Jhelum River. Further downstream, this same water will be turned through a series of barrages and link canals to irrigate the fields and increase the nation's agricultural yield. By 1975, Pakistan's growing economy will be consuming 1.75 million kilowatts. Over half that electrical power will be coming from the generators at Mangla, whose ultimate potential of 1 million kilowatts will make it the largest hydroelectric project in the nation. Already the engineers of the West Pakistan Water and Power Development Authority were in control. At their command, the waters of the Jhelum coursed through the tunnels and turned the generators that created power at Mangla. From Mangla, that new power would flow to the switchyard, where it would be directed to the lines that now crisscross the land. Lines designed and built specifically to carry electricity from Mangla to the growing cities and expanding industries of Pakistan. Electricity to light the streets and homes, the offices and buildings. Electricity to power the factories. Electricity for the new life that Pakistan is building. On the hill above the dam, old Mangla Fort would serve as the inauguration site for the Indus Basin Project. Touring the site prior to the ceremony are Guy F. Atkinson, founder of the company, which had served as managing partner of Mangla Dam contractors, and Richard A. Trappier, representing the partners. On the morning of November 23rd, 1967, all was ready. People came to Mangla not only from all parts of Pakistan, but from all parts of the world. Pakistan's President Ayub Khan would inaugurate the new dam. And now his motorcade passed across the top of the dam, approaching the dedication site. Down through the ages, other leaders had come to this desert-like land, but they had only passed through on their way to conquests or defeats, and had given little thought to what was then a broad, flat river plain. But today it was different. Important men had come here purposely, not on their way to somewhere, but to be here where men had built a dam that not only changed the course of a river, but of a nation as well. After receiving congratulatory messages from the participating nations, President Khan took the rostrum.
We meet here today a year ahead of schedule. That a project of this size and magnitude should have been completed in record time and a cost below the estimate.
To President Khan, the dam is a tangible demonstration of progress. Progress achieved through long-range planning. Planning to fulfill one purpose, the happiness and welfare of the nation's people.
I have now great pleasure in inaugurating the Mangla Dam, Pakistan, Hyderabad.
At the President's signal, the spillway gates opened. Water cascaded over the spillway. The first step in the Indus Basin plan had been taken. The work of 6.5 years was finished. Mangla Dam was complete. Now the men of Mangla Dam, the designers, Binney and Partners, the builders, Mangla Dam contractors, WAPDA, everyone concerned with the project knew that their work had resulted in another step forward for Pakistan. This dam, together with the old fort, represents a symbol for a nation that looks in both directions, to the heritage of its past and the promise of its future.